Good afternoon, everybody. Today my talk will concern the microplastic pollution in surface water and groundwaters in the south of France. This study was collaborative work between the French Institute INERIS, the Society PERKIN ELMER, and this work was carried out in the Laboratory of Chemistry and Environment. So before presenting our results on the detection of microplastic in the surface compartment, I just want to give you a few background information about microplastic detection. I think that most of you have heard about microplastic, which size is generally between 1 and 5 millimeters, and they have been mainly detected in sea surface water. You can see here some concentration of marine plastic debris that can reach around 0.03 microplastic per cubic meter. But also the microplastic have been detected in fresh surface water. A few studies focus on this contamination, and they put in evidence the contamination of rivers. In France, with concentration of around a few dozen of microplastic per cubic meters, but also in China, in Pearl River, with concentration of a few thousand microplastic per cubic meters. Concerning the groundwater, as you can see here, there is a lack of knowledge on the level of contamination by microplastics. And it exists only 5 publications in the literature, mainly outside of Europe, with some concentration that can reach around a few dozen microplastic per liters. So hence, concerning the detection of microplastics, it appears necessary for us to investigate the pollution in the French rivers and also in French groundwaters. For this study, we focus on 2 types of waters, so surface and groundwaters. Surface waters was 2 rivers, Arc and Rhône rivers, and we focus on 2 sites close to Arles and close to Aix-en-Provence. The first site close to Arles allows us to collect some samples from Rhône rivers, and the other site close to Aix-en-Provence, so downstream Aix-en-Provence to Pierrepont, allows us to collect in 4 stations Arc river samples. For groundwaters, we focus on 2 industrial areas with old and current activity on storage of non-dangerous storage waste. So to sample surface water and groundwater, we use 2 different protocols. The first one for surface water was involved the use of a Montanet with a mesh size of 313 micrometers. And we made 2 campaigns on Arc rivers and only 1 on Rhône rivers. For the groundwaters, we use 2 types of sampling methods, using firstly polytetrafluoroethylene bailer to collect the surface of the groundwater. And for the samples in the depth of the water column, we use a stainless steel submersible pumps connected to PTFE tubes. All the samples were stored in glass bottles at 5 degrees Celsius before analysis. So the analysis methods was the following ones. We used 2 types of methods. The first one allows us to analyze the large microplastics. I mean the microplastic with size between 1 and 5 millimeters. And the second one allows us to analyze the small microplastic with size between 20 micrometers to 1 millimeters. So the first protocol implies a step of sieving with manual sorting or a direct filtration, followed by observation with microscopy and confirmation of the polymeric nature of the samples by infrared spectroscopy. For the small microplastic, we use a multi-step sieving, followed by a digestion and a density separation, and analysis by infrared microscopy. So let's go to the results. On here, the large microplastics. As you can see here for the Arc River surface, microplastics were detected in all stations during both campaigns, with some fragments and also some biomedias, and the maximum of the concentration was reached in the second campaign for the station 3, with a maximum of 22 particles. This corresponds to a concentration of 0.11 particles per cubic meters, and many of the debris are in polyethylene and polypropylene. For the round surface water, we only observe a few fragments of plastic, as you can see on these pictures, mainly in polyethylene, with a lower concentration around 0.03 particles per cubic meters. In groundwaters, no large microplastics were detected, but some small fragments that can be analyzed by infrared spectroscopy. So let's go now to the small microplastics. So all the samples were analyzed by infrared microscopy, and in all the samples we were able to detect some small plastic debris. Here is the distribution of the microplastic by size, and here the distribution as a function of the polymeric nature of the plastic. As you can see here for the surface water of Rhone River, we have mainly microplastics with size in the range 25 to 250 micrometers. We observe mainly debris in polyethylene and in polystyrene, and this corresponds to a concentration of 1.2 microplastic per cubic meters. For the surface groundwater in the first site, you observe also the size distribution here between 25 to around 200 micrometers. The distribution of the polymeric nature changed a bit because we have mainly PP, so polypropylene, and also PVC, polyvinyl chloride. And the concentration is very higher because we reach a concentration around 400 microplastic per liters. For the second site and for the surface groundwater, we observe also a concentration lower than the previous one, with a concentration of microplastic around 80 microplastic per liter, mainly fragments in polyvinyl chloride, and the distribution is limited to 25 to 100 micrometers. For the groundwater collected in the water column, we observe that the concentration is higher, with a concentration more than 530 microplastic per liters. We found mainly microplastic in polyethylene, and the size distribution is larger, between 25 to 350 micrometers. So to conclude with this presentation, in this study, we put in evidence the presence of microplastic in French River, also large and small microplastic with a maximum of particles around 1 per cubic meters. We put in evidence also for the first time of the presence of microplastic, small microplastic in groundwaters, mainly in PP and PVC, with a size distribution range between 25 to 350 micrometers, and with a concentration larger than the ones described in the literature. So this result puts in evidence that there is a major concern for groundwater, as groundwater can be used as a source for drinking waters. So the perspective of this study are numerous, and among others, we can planify to work on the rigorous methods to determine the right concentration of microplastic in surface river, and also to investigate the potential relationship between microplastic in surface, soil, and in groundwaters. So I want to thank colleagues from my laboratory for their collaboration, some other colleagues from INERIS, Fabrice, Quiot, Nicolas Salle from SISMA Environment, and Alexandre Michelet from PERKIN ELMER. I want to thank also the students involved in this project, Vanessa, Lucas, and Jan, and also Conseil Général, Région Sud, et Real PACA for their financial support. And finally, I want to thank all of you for your attention.